Today we're going to be looking at the 2013 November Silver question, Pogo-Cow. So in this question, Farmer John is going to attach a pogo stick to Bessie. And so we're going to have a one-dimensional road, which is going to have n different targets. And if Bessie lands on the target, it's going to be worth pi points. And so when Bessie hops on her pogo stick, she's going to need to cover more distance, or at least as much distance as the previous hop. And she's going to need to land on a target. And so what we want to do is we want to calculate the total amount of points, or the maximum amount of points she can obtain. So let's go look at the algorithm for this question. So the main way we're going to solve this algorithm is going to be through DP. And so the first thing we can note is we can actually ignore the part about direction. And so what we're actually going to do is we're going to assume that we're either going to the right or to the left, and we're just going to assume that that's true. And so we're going to run two DPs. And the first one is going to assume that we're going to the right, and then we're going to reverse it, and then assume that we're going to go to the left. And so in this way, we can basically be able to run a semi-regular DP without having to care about the direction. And so what we're going to do is we're going to create a two-dimensional DP. And so the first dimension is going to be the current target we are on, or the current target we're starting on. And the second dimension is going to be the last target we were on. So if I started on, or I'm currently on, DPI, or DP4, and my last value was at 2, then what I can do is I can basically assume that I'm going to have my value here. And my value here is actually going to be a pair of two things. The first one is going to be the distance it took to get here, so the distance between target 2 and 4. And the second one is going to be the maximum amount of points. And the reason we're going to need this value here is because we're going to look at dpij. And let's say I'm going to transition or turn the value from dpjk to dpij. And so what we're going to need to do is we're going to check the amount of points in the distance in dpjk. And if the amount of distance here is less than the amount of distance between I and j, then that means that we can make a valid hop from j to I using the value here plus, say, pi. So we'd be dpjk, so the maximum amount of points there, plus pi, assuming we're going to reach target I. And so what we're actually going to do is we're going to loop through I, so our starting point, and then we're going to loop through past, which is going to be our j point, and then we're going to loop through v, and v is going to be our k point. And so v is going to go from 0 to dp past.size, so it's going to loop through all of the valid values in dp past. And then what we're going to do is we're actually going to look at dp past, and we're going to check the distance between I and past. And so if this distance is greater than or equal to dp past v dot first, then that means we can make a valid jump. And then we're going to create a value called CV, which is going to be the current value, and we're just going to find the maximum total amount of points possible for DPI past. And then at the very end, we're just going to find the maximum value overall. So let's go look at this in detail in the code. So I'm going to define LL as long, so anytime you see LL, it just means long. And so the first thing we're going to do is we're going to create our data structures. And so this question is relatively simple. We just need our targets, which are going to be written as a pair, and later the DP. So we're going to read in our input, and then what we're going to do is we're going to run two DPs. And the way we're going to do this is we're going to sort the value of targets. So this is going to put it in order. And then we're going to create two DPs. And so each one is going to contain a pair. Again, this pair is going to be the first value, the distance, and the second value, the amount of points. And then we're just going to run DP, create a second one, reverse the targets, so we're going in the opposite direction, and run the second DP. Now the next thing we're going to do is we're going to code our run DP function. So I'm just going to create a function so we don't have to copy and paste it twice, but the first thing we're going to do is we're going to set all of the DPs up. So we're going to have DPI, and for every value, we're going to push back distance 0 targets I dot second. And this is because when we have DPI, we're going to be starting at target's I, which means the distance is going to be 0, and the amount of points is just the amount in this current target. So this is assuming we're starting with target I. And then what we're going to do is we're going to loop through all of the values. And so when we loop through, what we're going to do is we're going to have 2 loops inside here. So we're going to loop on the outside from I, and then we're going to loop from past. And past is just going to assume we're going to jump from I to past. And so our distance between these 2 points, we can calculate, and I'm going to assign this into distance, or the value dist. And so what we're going to do is we're then going to do a second loop where we loop through a value called v. And so what v is going to do is we're going to assume that our current jump is going to be between I and past, and our last jump was between past and v. And so we're going to check dp past v. And so this is just looking at all of the different values we can go to using past and v. And we're just going to check if that distance was greater than our current distance. Notice that we're going from the greatest distance to the smallest distance. And this is because as we get closer, the distance is going to become less. And when the distance is greater than, or actually when the distance of our last jump is less than this distance, that just means that we cannot do any more jumps, so it's invalid. And so we're going to start here from the greatest possible distance going down until we have to break. And so we're going to assign this into current value, or CV. And so CV is just going to be the max of itself and the amount of points that we get from past V plus target's I dot second. And so this is just going to be the value. And so what we're going to do is we're going to push back distance, so the amount of distance here, as the first parameter, and CV as the current amount of points that we can get. And we're going to push that back into DPI. So this is going to be a 2D DP, even though it looks kind of like a 1D DP. But then what we're going to do is our answer is just going to be a global variable. And so it's just going to be the maximum of itself and CV. And so this is going to compare with all of the different possible values, regardless of what point it starts at. And at the end here, we're just going to have run both of these. Since answer is global, it'll have already updated, and we're just going to output our answer. And that's the end of our program.